This is 7th grade 4.1, page 165. Make sure I'm in the right grade here. Yep. Okay, this is called prime factorization. I think we kind of covered this before. One thing that's not on here that I would like to add to the vocabulary is the word factor. Okay, a factor are the numbers that multiply to make a product. For example, let me put an example. 3 times 5 equals 15. 3 and 5 are factors of 15. 3 is a factor of 15. 5 is a factor of 15. So basically a factor divides evenly into a number. So there's my factors right there. So the reason why I want to define factors because prime numbers and composite numbers and everything, you'll notice in prime factorization has the word factor in it, and factor tree has the word factor in it. So I think it's important to remember what a factor is. So if you guys will look, prime number, and I'm on page 165, a prime number is a whole number greater than 1. I'll just use a little bit of whose only factors are 1 and itself. Okay, so an example of a prime number would be 7. The only thing that can go into 7, or the only multiplication problem that makes 7 is 1 times 7. 1 and 7. The only things that can go into 7 evenly. So, and in other words, it only has a number that only has 2 factors. Okay, and 1 is one of them, 1 in itself. Okay, so a composite number, on the other hand, is a number with more than 2 factors. For example, 12. Okay, the factors of 12, 1 and 12. Now we spread them out, 2 and 6, 3 and 4. There are 1, 2, 3, 4, 5, 6 factors of 12 for a composite number. Okay, so then we go to the next one, prime factorization, and I kind of get off always on these. I guess I don't leave enough room, so I'll draw a line down here. Okay, that's when you can take a number and write it as the product of prime numbers. Okay, so for example, the first prime number is 2, then 3, then 5, then 7, 11, and so on. And I bet in the back of your book, sometimes there's a good resource in the back. I know that in the algebra book they give a list of the square numbers. I'm just wondering if the back of your book doesn't have a list of all of the prime numbers. I'm just looking back around in page 700 somewhere. There's squares and square roots. I was thinking there might be. I think you could probably Google it and go online and find all of the, like the first 100 prime numbers. Not that we'll ever use that many, but that's just a neat, would be a neat tool to have. Maybe I will put that down, that I will Google that and see if I can find, that. Let me, right now I'm going to make a note of that so I don't forget. You know, my old mind will forget. Google first prime numbers. Okay. So, a product of prime numbers, and we'll come back to that in a second. We'll talk about what that is. A factor tree is a method. It's a diagram my pin won't write. It's a diagram that will do that. Okay, it'll diagram that will find. Let's not find, F-I-N-D. Find the product of the prime numbers. All right, and we'll definitely be using the factor tree in the examples. So let's move ahead to our first example. Example number 1, writing factors of a number. A field trip. A class of 36 students is on a field trip at an aquarium. The teacher wants to break the class into groups of the same size. Find all the possible group sizes by writing all the factors of 36. Well, now in your book, they write them where they're thinking of numbers that multiply, and I'll show you 2 ways you can write. You can just go through and you can think, what are all the multiplication problems that make 36? Well, 1 times 36, 2 times 18, 3 times 12, 4 times 9, nothing 5, 6 times nothing, 6 times 6. And without, I mean, we could flop them around, but if we flop them around, then we see that, you know what, they're going to be the same numbers, because the next number after this would be 9. I don't like to do factors this way because sometimes I feel like I'm going to leave them out. What I like to do is I like to do them horizontally. I start, 1 goes into every single number. 1 is a factor of every number. So I start with 1 and 36 and I leave some room in between them. Then I just work my way up the numbers, and I'm also going to give you guys or remind you guys of this little thing called divisibility. Okay, after you watch this podcast, you need to come see me for the rules for the cheat codes for divisibility. Okay, I will give you a copy of those. I will run through them real quick, and here's what I mean by divisibility. I know a number can be divided by 2 if it's even, and I'll give you a copy of this. You don't have to write it down. It's divided by 3 if you add up the digits, and 3 can go into it. Okay, so 3 plus 6 is 9. 3 can go into 9, so 3 can go into 36. So let's start with 2. 2 can go into 36 because it's even, and I know 2 times 18 is 36. I know 3 can go into 36 because 3 plus 6 is 9, and 3 can go into 9, so 3 goes into 36. And you might, if you're not sure how many times, you'd have to go over here and do a little division problem. Okay, no problem. That, look, it comes out to be 12, and you should have these memorized. I know, and then the next, you just work your way up the numbers. 4 times 9, and then 5 won't go into 36, but 6 will go into 36. 6 times 6, so you only write it once. So if you work your way in like this, work your way in, then usually you don't forget one of the factors, unless you forget 2 of them, but a lot of times it just is a good way to work your way through finding the factors of the numbers. All right, so there's finding factors. And come see me get a divisibility chart from me to include with your notes in this lesson. Here they are doing all the multiplications. And then they said to stop because you didn't want to repeat. Notice those are the same things we got. So you could have, let's look at it this way, you could have 1 group of 36, you could have 2 groups of 18, you could have 3 groups of 12, 4 groups of 9, 6 groups of 6. Then you can also flip it the other way. You could have 36 groups of 1, 18 groups of 2, 12 groups of 3, 9 groups of 4, and then again there we have our 6 groups of 6. Okay? All right, so example number 2, telling whether numbers are prime or composite. Let's go back to our vocabulary. Remember, prime is if the only thing that can go into them are 1 in itself. Composite is if anything else can go into it. And here's a rule for composite that will help you. If the only even prime number is 2. Every number higher than 2 that's even, 4, 6, 8, 10, 12, all of those are going to be composite, because more than, see, 1 and 4 can go into 4, but what else can go into 4? 2. 1 and 6 can go into 4, but what else? If you can find any number besides 1 in itself that can go into it, then you know it's composite, because composite says more than 2 factors. So check out 56. You know 1 and 56 can go into 56, and you automatically know 2 can, because 56 is an even number. So because 2 can go into it, it's composite. Now there's other numbers that can go into 56, but we don't care. We just need to find, if we can get at least 3 numbers that go into 56, we know it's composite. Okay, think about 11. What's 1 times 11? Is there anything else that can go into 11? besides 1 and 11? No, so then it would be a prime number. And there they wrote out all the factors, but to me, you only need, once you get that third one, then you're done. Okay, so your guided practice, write all the factors of the numbers. So let's do this. I think it's just so 1 and 35, because 1 can go into everything. Okay, and then we go to 2. Can 2 go into 35? No, because it's not even. Then you go to 3. Can 3 go into 35? No, because 5 plus 3 is 8, and 3 won't go into 8. Can 4 go into 35? No. 5 can. 5 and 7. And notice as we worked our way down, the only number left is 6, and 6 won't go into it. So these are the numbers that can go into 35. Okay, 32, so this one's going to be a little bit 1 and 32. Okay, I know 2 can because it's even. Half of 32 is 16. 3, nothing times 3 is 32. 4 times 8 is 32. 5 won't go into 32. 6 won't go into 32. 7, so we're done. 1, 2, 4, 8, 16, and 32. Okay, 65, 1 and 65. 2 can't because it's not even. 3, no. 4, no. 5, and I think it's 13. Okay, 6 won't go into 65. 7, 8, no. 9, no. 10, no. 11, no. 12, we're done. 23, look what they were nice to us right there. The only thing that can go into 23 is 1 and 23. There's nothing else in our stuff that makes 23. All right, ooh, there's some guided practice that we missed here. I see they skipped some, so I'm going to go ahead and just let me see if it happens to be. Those should look familiar to you guys. Oh, they did. They don't have them. So I'm just going to put them over here on the side. Over here. Number 5, on the guided practice, number 5, 47. We're supposed to tell if 47 is prime or composite. Okay, well, I'm thinking of my facts. 47, the only thing I can see that goes into 47 is 1 and 47. 2 won't go into because it's not even. 3, no. 4, no. 5, no. It doesn't end in a 5 or a 0. 6, no. So that would be prime. Okay, number 6 is 81. Automatically, I know 1 and 81 can go into 81, but I know 9 times 9 is 81, so automatically I know that is composite. Number 7, 34. Because it's even and it's such a high number, it's composite because 2 can go into it besides 1 in itself. Number 8, 67. And sometimes everybody thinks those odd numbers are, but pretty sure that one, there's nothing that I can think of that can go into 67. So then it would be prime. So we got 8 problems so far on our guided practice. Let's talk about doing the factor trees now. So example 3, using a factor tree. Use a factor tree to write the prime factorization of 54. So a factor tree, you start with the number. You start with 54 and you branch off of it. And this should look, we've done this before. You branch off of it and you think, I need 2 numbers that make 54. Now the rule in factor trees is this. You cannot use a 1. Okay? We can't use a 1 because this is a prime factorization we're making and 1 is not a prime number. So they chose to start with 2 and 27. Now, when you end, notice when you can stop at the end of a branch when you have a prime number. 2 is a prime number. So notice they just carried that 2 all the way down. I usually don't do that. My tree would look like this. 54, if I did the 2 and the 27, I would put 2 times 27. I stop right there. I circle it because 2 is already prime. I can't go anymore. My job is to make these numbers prime. So I think 2 numbers that make 27, and I can't have a 1, so that would be 3 and 9. 3 is already prime, so I stop and I circle it. There's the 9, and 9 is 3 times 3, and they're both prime, so I stop and circle those. So what we're doing is look what they're doing right here. It said factor 27, which is what I did right there, and then it said factor 9, which is what I did right there. So there's a lot of different methods on how to do prime factorization. Let's see what their other tree looks like. They chose to start, let me erase this. They chose to start, as long as your two numbers make 54, look at this one. They chose with 3 and 18, so let's do it my way with the 3 and the 18. 3 and 18, 3 is already prime, so I'm going to stop. 18, I'm going to go, they did 3 times 6, you could do 2 times 9, that still makes 18, circle it. 9 then would be 3 times 3. And if you remember, that's exactly what I had before, 3 3s and 1 2. Okay, another fact, let me see if they do another way. Okay, both trees give the same result. How about this? You can do something called upside down division. Check this thing out. You start out here on the side, you start with a prime number, like for example, the 2. And you say, how many times does 2 go into 54? It goes 27 times. And then you start again, what's another prime number that will go into 27? 3 goes in there 9 times. And 3 goes into 9 3 times. You stop when this number is prime, and there's your prime factorization. So upside down division is another way to do find the prime factorization. It's just a variation. It's not a factor tree, it's just a different way to come up with the same answer. Okay? Now, as far as the result goes, check out what they do right here. They write it 2 ways, and I want you to write it both ways for me. Maybe the book will tell you which way to write. This is called expanded form, 2 times 3 times 3 times 3, and this is called exponent form, 2 times 3 to the third, because of the 3 3s right here. Okay, we're going to use both of these forms when we do greatest common factor and least common multiple, so that's just a FYI. Okay, so use a factor tree to write the prime factorization of 30. So we're going to branch off of 30. 3 times 10 is 30. 3 is prime. 10 we branch off of it. 2 times 5. They're both prime. So that would be 2 times 3 times 5. Or you could use the dots. And notice when I write it, I'm writing it in numerical order. Make sure you do that. Let's try my upside down division. Let's start with 2. 2 goes into 30 15 times. Let's put a 3. Remember, any number out here on the left side has to be prime. And I'm done. There's my prime factorization. 2 times 3 times 5. Let me do some erasing here. Okay, 48. Let's see. How about 2 and 24 make 48? I'm done with the 2. 24 I branch off. How about 3 times 8? See where it's nice to know your multiplication facts. 2 times 4 and 2 times 2. And you know why I'm circling those numbers? I circle them because they're prime. I can't go any farther. So that would be 2 times 2 times 2 times 2 times 3, or 2 to the 4th times 3. There it is. Okay, 44. 4 times 11. 4 breaks down into 2 times 2. Prime, prime, prime. So that would be 2 squared times 11. And it's there. You can see it. Okay, 75. Let's go over here. Let's do it with the upside down division this time. 5 goes into 75. That has to be prime, so I can't remember how many times 5 goes into 75. Once. 15 times. And 5 again into 15 goes 3 times. They're all prime now, so when I write them in numerical order, 3 times 5 squared. That's it. Okay, didn't we already do those? No, that's the ones we did later. I added those. Remember that? I'll go through those. All right, that's it. Writing them out. Make sure in your instructions if it says to write your prime factorization, go ahead and write them both ways. Excuse me, one with the expanded form, and the other way would be the form with the exponents. All right, come get a divisibility chart from me also. Thanks. See you next time.